So on the collection of sets, we have multiple operations which we will define. And the first operation, which is a binary operation that we define, is the A union B. Okay, so the union operation. So in the union operation, we are looking at, okay, so this is a collection of all elements that are either in A or in B. That does not mean that it has to be exactly in one of them. So it's not an exclusive OR as in computer science. Okay, so this is either in A or in B or in both. But the element must belong to at least in one of the A or B. So when an element belongs to the set, we denote it by this symbol. This symbol means X belongs to A. And using that symbol, we formally write X belongs to A union B if and only if X belongs to A or X belongs to B. So that's the definition. So X belongs to A union B if and only if X belongs to A or X belongs to B. The first property is that this operation is commutative. So A union B is same as B union A. So X belongs to A or X belongs to B. Another way of saying that is X belongs to B or X belongs to A. So it is exactly the same, so it is commutative. The operation is also associative. How do you show that the union operation is associative? What you have to prove? We have to prove that A union B union C is equal to A union B union. So let's look at X as an element in A union B union C. And we will show that X is an element in A union B union C. And then we will show that if X is an element in A union B union C, it is also an element of A union B union C. And in that way, we will prove the equality of these. So proceed.
So this means that X belongs to either A union B or or C.
So this means that X belongs to A union B or X belongs to C.
And you can break down that A union B further, which means that X belongs to A or X belongs to B. And we can break down the
now you combine. So now you combine. So this is X belongs to A or X belongs to B union C, right?
Yes. Which means X belongs to A union of
X belongs to A union B union.
B union C.
So what we have shown? We have shown that any element which is in A union B union C is also an element in A union B union C. Now, if every element of one set is in the other set, we say that the other set is a superset of this, or the set from which we have taken the element is a subset of this. So what we have shown is that A union B union C is a subset of A union B union C. Okay, now let's do the other one. So let X belongs to A union B.
So X belongs to A or X belongs to B union C, which means that implies that X belongs to A or X belongs to B or X belongs to C, which means that X belongs to A union B or X belongs to C. So X belongs to A union B union C.
So what we have proved here?
We proved that A union B union C is a subset of A union B union C.
So when we have two sets where X is a subset of Y and Y is a subset of X, then we can assert that X is equal to Y. So using this fact, we will be able to conclude that these two are equal. So it is commutative, it is associative, it is idempotent. That means if you have A union A, you get A. And if you have this null set is the set which has no elements. So a null set is a set by definition. So this is the set which consists of no element. So given any object, and the answer to the question that is this element in the set is no. And this is typically denoted by the symbol phi. If you take A union phi and phi contains nothing, so that will again give you back A.